Hello everyone, I'm Chia Liu and I'm from Group 12. Today we are going to talk about pendulum. This is our outline. First part is the motivation. And the second part, we are going to deduce the mass part of a pendulum. And the third part is our simulation. We simulate the motion of pendulum and analyze them in three ways, including the online simulator, the Python we use, which we will coding and do the animation. And final, we will make the real pendulum. And then is our summary. Okay, let's begin with the motivation. There are three reasons why we choose pendulum. First is the interesting history. And the second is the various application of pendulum. We are also inspired by the art created using pendulum, which is very cool and groundbreaking. Okay, in 1602, Galileo is the first person found the crucial property of the pendulum. And in 1656, Christian Huygens built the first pendulum clock. This was a great improvement over existing mechanical clocks because their best accuracy was improved from around 50 minutes to around 50 seconds a day. Besides, once the pendulum was invented, many of our ancestors have done something interesting with it. For example, they used pendulum to make people fall into a trance and do divination for him. I think this is very cool, but a little superstitious. But I do appreciate a unique culture because it was amazing if it really works. Also, people use it to locate water, gold, oil, and missing objects. I think it is like the old school style of GPS hundreds of years ago. And the third way they use pendulum is the most famous and insane. The pendulum was used by witches to communicate with the spirit guides. Spirit guides is an entity that has no physical body and they can protect human being in their back. In other words, this is just like the angel. Okay, this were our three motivation, and then I'm going to talk about the modern application of pendulum. The next application I want to introduce is the metronome, which helps maintain the speed of music. For example, when we play an instrument like guitar, we need to practice with a metronome to feel the sense of tempo and follow the tempo, which is very important for a musician. Even if the traditional metronome have been replaced by some electronic devices, the original physical principle of metronome is still the pendulum. Okay, the next application of pendulum I want to introduce is the tune mass damper. I think many of you have seen this in Taipei 101. Between 87 and 92 floor, there's a giant yellow big ball hanging in the middle of the building, which is exactly the tune mass damper. As you all know, Taiwan is a country which is vulnerable to the earthquake and typhoon, so it's very important to avoid oscillation as much as possible, especially the floor is that high. So this technology is so-called the vibration control technology, which is used to reduce the mechanical vibration and dynamic interaction of the building when it is influenced by the external force, like typhoon or earthquakes. Okay, so why the damper is across the 4 floors? This is because of the physical principle of the pendulum. In order to reduce the vibration, the damper have to perform anti-resonance. However, to perform anti-resonance, the frequency of the building should be as same as the frequency of the damper. Once we know the frequency of the building, we can calculate the frequency of the damper. And if we know the frequency of the damper, we can view the whole structure as a pendulum. And what's more, if it is a pendulum, we can calculate the length of the pendulum, which is exactly how high we should hang the damper in the Taipei 101. As you can see, we can calculate the length of the pendulum. It's equal to the 11.5 meters. So this is why the damper is across the 4 floors on the Taipei 101. Okay, the third motivation of why we do the pendulum is because of the beauty of pendulum. This is called the pendulum swing art. The artist used the pen hang on the air and just let it sway above the paper. This kind of art is easy to make, and there's many videos on YouTube. The reason I think this is amazing is because I think the art is the combination of science, art, and math. So that's all the 3 reasons why we choose the topic, because of the interesting history, the many application of the pendulum, and the incredible kind of the art it created.
Hi, I'm Zheng Bohong. I'm going to introduce the math part. First of all, look at the picture. A pendulum contains a string and a stop binding in the end. Because the stop's motion trajectory is a part of the circle, when we analyze its motion, we need to set the arc as x-axis, and the force need to be partitioned into a direction parallel to the arc and a direction vertical to the arc. The force parallel to the arc causes the difference of velocity rate, while the vertical force causes the difference of velocity direction. Here we only consider the force parallel to the arc because we already set the arc as the x-axis, so the direction is already concerned in x-axis. Consider F equals to ma. The m represents the mass of the stuff. The a is its acceleration, and the F is the force on the stuff. Set the right direction is positive direction, so force on the stuff is negative mg, which is caused by gravity. Since we only consider the partition parallel to the arc, the F is negative mg sine theta. Theta is the angle between the string and the perpendicular line. When the theta is small enough, the sine theta is approximate to theta. So the formula can be rewritten as negative mg theta. When the motion is concerned as a part of the circle, the radian is arc length divided by radius, which means the theta is x divided by L. L is the length of the string. F can be rewritten as equation 1. Compare this formula to the SHM formula. We can find that mg divided by L is the parameter k. So when the theta is small, the pendulum system is simple harmonic system. And now we can use the period formula of the SHM. The SHM equation is equation 2. The k can be replaced by mg over L. So the period of the pendulum is 2 pi multiplied square root of L over g, like equation 3. To sum up, under condition that the angle is small enough, like about 10 degrees, because the period equation only contains parameter L and g, which is the string length and the acceleration of gravity. The mass of the stuff and the angle don't influence the period.
Hi, I'm Tinan Guo, and now I'm gonna introduce our simulation. We have 3 ways to simulate the pendulum situation. The first is an online simulator called Pendulum Lab, and it can change different parameters like length, mass, gravity, and the initial angle. And it can count the period of time. So we setting 6 experience groups, changing in length, angle, and mass in Table 1. And after using the simulator, we got the consequence t in Table 2. And you can see that even changing in mass, t doesn't change. Group 1 to Group 4 has corresponding consequence to Group 5 to Group 8. It proves that if we don't consider the damping or resistance effect, no matter how big or how small in mass, the same length and same gravity will have the same period. And you can see that when the lengths are getting small, the period will getting small too. And the angle getting bigger, the arrows will getting big. Another thing we're gonna discuss is the theoretical value from the equation t is equal to 2 pi squared t divided by g. It supposes that angle is small enough that sine theta will approach theta. So we plan the table 3 to discuss 6 small angle pendulum and observe the arrow on theoretical value. You can see when the angle gets bigger, that the value of t gets more away from the theoretical value, and it agrees with the equation.
Hi, I'm Ethan from Group 12, and after introducing the online simulation, I'll go for the Python simulation. And Python is a powerful, a strong, super good language. So Python is our first choice when talking about programming. For Python simulation, we haven't written a full code, but we have think of some blueprints. So let me introduce what are we going to do by Python. G for the gravity, L for the length of the pendulum, and M for the mass of the bob, and theta 0. When we got those parameters, we start solving the ODE and get theta with a given t, which is the time of the system. So after we calculated the theta, and we could make the animation of SHM and the pendulum simulation. In order to do this, we need several functions, such as the function for solving equations, the function for plotting, and the function for animation, which is combining different plots, and it will make it an animation. And when we're researching for how to realize the pendulum simulation in Python, we found that we could import a model called matplotlib.animation, and by this module we could make an animation. This is a plot and animation we wish to realize. The first one is a simple harmonic motion. The x-axis is the time and the y-axis is the amplitude. So the plot will look like this. It is a sine function, and we wish to plot this by our Python simulation. The next plot is the pendulums simulating. We will make this into a animation, which would simulate how the pendulum is moving. After we've done our Python simulation, we will do a physical realization. So here's an example. Okay. Prepare 2 weight negligible rope for 0.5 meters and 1 meter and 2 different weights. do the experiment at different parameters of table 1 and observe the difference between the experiment results and table 2. So if we're going to realize the pendulum, we should have 3 basic elements: a fixed point, a rope, and a bob. The variables are the rope length, releasing angle, and bob weight. So when we're realizing, we're going to compare these results with our simulation results. We'll make different charts of different variables. For the summary, we'll do online simulation and Python simulation. Then finally, compare the results with our realization. After comparing, we might find some problems, and the point is we should find out what makes the difference between our simulation and realization. And finally, fix either simulation or the way we realize the pendulum and make the result better. Here are our references, and this is our midterm project. Thank you.